So I want to do one last example with you showing the Coase theorem and how people can negotiate to get to the optimal outcome, even if their individual incentives may not lead them to do so. So imagine that Abercrombie is a company that dumps toxic waste into the river, and Fitch cannot fish the river if that's the case. So no one else is harmed. Abercrombie could install a filter to remove the harm to Fitch. The filter imposes a cost on Abercrombie, however, so that makes him less likely to want to do it, and the filter benefits Fitch, which makes him want Abercrombie to do it. So assume that these two parties cannot communicate with one another, and this would be the gains to each firm. So if Abercrombie operates with a filter, he'll make $100 a day because it has to spend $30 to install the filter. If he doesn't pay the $30, then he can make $130 a day from his normal day-to-day operations. Fitch, on the other hand, he would get $100 a day from his fish if Abercrombie used the filter, but if he doesn't use the filter, then the pollution is going to scare away or kill half of the catch, and so he can only make $50 a day. Now, to determine which of these two options is the social optimum, what we want to do is add up the total gains to each party. And so as you can see, without a filter, Abercrombie's 130 plus Fitch's 50 gives us $180 of gains per day. But if we operate with a filter, then each person will get $100 per day and we'll end up with this $200 a day outcome. And so it turns out that operating with a filter is socially optimal, or is the efficient outcome, and this is the inefficient outcome because there's less gains to be had. So it turns out that Abercrombie's not going to install the filter in equilibrium because the two parties can't communicate, and there's no law that says Abercrombie has to install the filter. So his own self-interest, his own personal gain is going to say, look, I would rather operate without the filter, so he's not going to install the filter in equilibrium. The marginal cost of the filter is 30. That's way less than his marginal benefit, so he's not going to do it. However, the marginal benefit to Fitch is $50 a day, so if these two could communicate, maybe the outcome could be different. There's a net loss of $20 a day going on here because if there was with a filter, then the total gains would be $200, but without the filter, the total gains are only $180, so society has lost $20. Now assume that these two can communicate. The payoffs are going to be exactly the same as the last example, but now they're going to be able to talk with one another. And so what's going to happen is Fitch is going to realize that if he pays $30 to Abercrombie, Abercrombie would be willing to install the filter because then this $100 he would get with the filter plus the $30 he would get from Fitch would bring him back to the same level of profit he would get without a filter. Clearly, Fitch has up to $50 worth of gain from Abercrombie installing the filter, so he'd be willing to pay up to $50 to get that done. So that means somewhere between $30 and $50 there is an outcome where Fitch could negotiate to have Abercrombie install the filter. And so that's what the Coase theorem is all about. It says if the two parties could costlessly communicate or costlessly negotiate without transaction costs, then these two would arrive at the optimal location or the optimal outcome because Fitch would be able to pay between $30 and $50 to Abercrombie to alleviate the difference between the two. Okay, so the Coase theorem says that if people can negotiate the right to perform activities that cause externalities, they can always arrive at efficient solutions to problems caused by the externalities. Negotiations must be costless, which we know never really happens if you listen to the podcast, and sometimes those harmed will pay to stop pollution. So in this case that we just did, Fitch would pay Abercrombie. Sometimes the polluter buys the right to pollute, and so that happens in the current system with electric power companies. They have to buy emissions permits, and so they have to buy the right to pollute. And in that case, Abercrombie would pay Fitch. So let's see another example where Abercrombie's company produces toxic waste, but in this case, laws prohibit dumping unless Fitch agrees. So now it's a different setup. So notice the payoffs are going to be slightly different. And now the optimal outcome is to operate without the filter. And so Abercrombie is going to gain $50 a day from operating with a filter. Fitch would only lose $30 a day if Abercrombie polluted in the river. So if this was left just up to themselves, Fitch wouldn't let Abercrombie pollute. $100 a day is bigger than $70 a day. So if there was no communication, Fitch would just say, no, you can't pollute. I would rather make 100 than 70. But if these two could communicate, Abercrombie would be willing to pay up to $50 to install this filter. And Fitch should be willing to accept anything over $30. So again, we have this range between $30 and $50 where these two could arrive at the efficient outcome. So Fitch would accept any offer over 30, Abercrombie would be willing to pay up to 50, and so in this scenario, it turns out polluting is the social optimum, and we can arrive at that location if and only if these two are allowed to negotiate with each other, meaning that they have the ability to communicate. So that's essentially the Coase theorem. Hopefully this example will help you out with some questions on your homework and ultimately help you out with a few questions on the final exam. All right, have a great week, guys.